chemical equations. So you're in the one way to start figuring out how much you mix this and this. We need to make this. How much are we going to get? You know, instead of doing the experiments all the time, you can actually, write it all out on paper. You can't be an experiment though, because things go wrong. All right, or we're not going to get that much because, I don't know, maybe you don't get 100%. Things don't mix perfectly and things don't react perfectly. Right? Because for things to react, they have to actually collide. So, things don't always work to 100%, but it's nice to actually be able to do things theoretically. All right, so there's eat some chili. You get some chemical processes in your stomach going on there and your innards. Which one of these is flammable? Right? You've heard of people lighting these. Which gas in there is actually flammable? What is it? Yeah. What's the name of this one? Methane, natural gas, right? Which one makes it stink? The H2S, the hydrogen sulfide. Whenever you see sulfur, think of stink. I don't know. Our nose does not like the smell of sulfur compounds. Okay. So you can talk about some nasty stuff without even actually witnessing it. Balancing chemical equations. Ashlands, we have reactants and we have products. Which is which in a chemical reaction? Yeah, products are what you end up with. Reactants are before the arrow. Exactly. Okay, so we have these molecules, I guess, or Victoria, does it look like molecules or does it look like ionic compounds flying around here? Yeah, molecules, right? Definitely molecules, not crystals. And so each little sphere, they're kind of jammed together. Each little sphere is supposed to be a Adelpho. What is each little sphere supposed to be? I mean, you have black ones, red ones jammed together. Yeah, elements, right? Different elements. Atoms of different elements. Okay, so if we're looking at this, Christina, does it look balanced? Because remember who it was. I think it was Dalton who said that, man, it's a lot easier to introduce a planet into a solar system than it is to create or destroy an atom of hydrogen, right? So you can't lose these things, these atoms. Christina, does it look balanced? It's kind of hard to distinguish colors, but what would you be looking for to see if it is? Yeah, the same atoms over here have to be the same atoms over here, right? So I guess you have one black sphere, and here it is. You got one black sphere. 1, 2, 3, 4 of those blue spheres. 4 blue spheres on the products? Yeah. And 1, 2, 3, 4 reds. 1, 2, 3, 4 reds. It works. Okay. But you'd have to be an artist if you want to keep up doing it this way, so we're not. If black, red, and blue represent carbon, oxygen, and hydrogen. So black is carbon, red is oxygen, blue are the hydrogen atoms. Write a balanced chemical equation of the above reaction. Okay. So, Paulina, I'll get you started. I'll put in the little plus doohickeys. Which isn't a whole lot, but something. What would you write? Yeah, now the black is supposed to be C. A C. Okay, now she's looking at this one, right? Oh, good. Now where do you put the 4? On a subscript. That is key. Right? That's exactly what the subscript means. It means that you've got 4 of these hydrogens, chemically bonded to one carbon. And notice she said CH4. I mean, she technically could have said C with a 1, but no one ever writes the 1s for some reason. Kind of wish they would. It'd be clearer, but maybe it looks nicer. I'm not sure. Okay. Keep going, Christian. Okay, now. Yeah, they're H's, right? Because H are the red ones, right? No, H aren't the red ones. What's the red one? Oh, reds are the O's. Yeah, I was getting confused too. Because the red has to be the O's. It's not H's, but O's. So what would we write here? Now there has to be 4 total. She says a 2 in the front and a 2 subscript. She is right. Why? There's 2 separate ones, exactly. And the 2 separate ones is the first 2. There's 2 separate molecules. That's why you have the first 2 out there. Do you still have 4? You can easily see 4 atoms of oxygen up here. But can you see 4 atoms of oxygen down here when it's written? You just what? Just multiply them, right? You have 4. Or you could write O2 plus O2, same thing. But it's a lot easier to write 2 O2s, right? I forget who I asked, but they could have just said this. But it's too much writing, right? It's a lot easier to just write 2 O2s. Okay, now we've got the products. David, what's the first one? CO2. CO2. Okay. And now how did he know to say the C first? Why isn't it O2C? It does sound a lot better. We've heard of carbon dioxide. And we're going to get to that later. So what if you wrote O2C? I'm not going to knock it off. I mean, how the heck would you know? Okay. And then the next one, Brianna. Okay, we got 2OH2. All right. So we've got 2 of these guys. I like that. And there's an O and 2 H's. All right? There's just another way you could write this, but there's nothing wrong with this. 2H2O, same thing. Doesn't matter, right? But you've probably seen it. All right, the more common way to write it. 2 OH2s. This is how she said it. Brianna said it. Is really the way it should be written. And again, that's following the rules why C is out front. And we'll talk about that later. We really don't care right now. We'll be writing Lewis dot structures and figuring out what the center atom is and stuff. But either way works. Helpful hints for balancing chemical equations. Oh, before we even move on here. Is this balanced? Is that chemical equation, Stephanie, the actual mathematical equation, using all these symbols and things, is it balanced? Yeah, I would say so too, just because we got it from something that's balanced. But how do you check? Let's say we didn't have these, and we're never going to have them again, all these nice little molecules up there. What do you look at to see if it's balanced? The individual elements. So like, on this whole side, on the reactant side, how many carbons do I have? 1. On this side, 1. See, that's all you're going to have to do every single time. And on this side, how many H's do I have on the reactants? 4. And on this side, I have 4. And that's key. Let's kind of multiply the 2 times the subscript. And then, oh, the oxygens. How many oxygens on the reactant? 4. The product. A little harder to see, but it works. I've got 2 here, and I've got 2 here. I have 4. So it's important to be able to see that. Otherwise, you're going to have a hard time today. Okay. So pretty much the game we're going to be playing today, let me show you, is this. Erase all the numbers out front and put blanks. That's the game we're going to be playing today. And to me, it really is a game because it's just random. I mean, you could just randomly start throwing in numbers. But there is a method to the madness, and that's kind of what I wrote down below. And to me, this is key. This is going to help out a lot, this first one. If we had to balance this guy. Balance last any element that occurs by itself somewhere in the chemical equation. So, Lauren, if we were going to try to balance this chemical equation up here, which one would we work on last? Which element? Lauren. Which element would... It has to be one all by himself. Oxygen, right? Because carbon, now he's stuck with hydrogen, right? And, well, over here you have oxygen stuck with hydrogen, but I guess you have oxygen by itself at least in one spot. So you leave him for last. Okay. So I would probably start out with the C's. C's are good. Leave them alone. And then remember, to do oxygen last because he's got this number out in front. Right? He's got nothing there in front of him. He's just all by himself, so leave him for last. So I'd probably do the hydrogens next. And if you do the hydrogens next, how many hydrogens on this side? 4. So put a 2 there. All right, that's what I would do. This logically. Now I've got 4 hydrogens on both sides. But now I've got how many oxygens on the product side? 2 plus... Yeah, don't forget this guy. I've got 4. So that means I put a what in front of the O2? A 2. And that's the game we're going to be playing. And you can balance other things first, just that it's quicker if you leave the elements by themselves, even though... Leave the elements by themselves, do them last. Your life will just get a lot easier. Okay. The second thing we need to remember, and the homework is going to say, this stuff is burning, it's on fire, we're having a combustion reaction. And the products are always what and what, Erica? They just want you to, they assume you know this. What do you get when you burn stuff? What and what? Where's Erica? What do you get? Anybody help her? Erica? Water's one of them. Yeah. And, oh, she got it. Carbon dioxide. You burn stuff, you get carbon dioxide and water. Just remember that. That'll help you out. Okay. Let's try some of these. So, Gloriana, which element would you like to try to balance first? Well, hang on, Gloria, before I even ask yet, let's ask, where's Gloria? Maybe this is balanced. Maybe there's nothing to do. Do you see something wrong that shows that it's not balanced?
Yes.
Like what?
There are 2 NAs to the left.
Yeah, okay, good. There's 2 NAs here. And how many NAs on the 3? Right? So it's messed up. Did everybody see that? It does need balancing. We can't just all of a sudden pop up with a sodium atom. Okay, that can't happen. So Marco, what element do you want to balance first? Yeah, okay. Just don't say what is what I'm shooting it for. I'm hoping Marco doesn't say what. Just don't say which element. You want to see what I'm trying to get at? Iodine. Just don't say the iodine, because it'll be sitting here longer. So he says oxygen. Fine, I don't care. Oxygen. Okay. So, Maria, let's balance the oxygen. How many oxygens over here? 3. And how many over here? 6. So how are we going to get them to balance? Well, not a 3. Put a 2, right? Because 2 times 3 would be the 6. That makes sense? Because it's not, you can't add them. You have to multiply. You have to multiply. So 2 times 3 would be 6 oxygens on that side. And now we have 6 oxygens on the product. Good deal. So Bianca, leave those oxygens alone. Now what? What could you do next? Sulfur. Okay. How many sulfurs, Bianca, on the reactant side? 4. And keep going. How many sulfurs on the product side? 4. Oh, good. Let's leave those sulfurs alone. Gloria. Now what? Oh, we did the oxygens. 2 times 3 is 6. Remember, I forget who I asked, but someone did the oxygens. We did the oxygens. We did the sulfurs. And remember, do this guy. Iodine's last. The only one left would be the NAs, which is sodium. Everybody, how many sodiums on this side? 4. How many on this side? 3. All right. Now, if we put a 2, if you mess up this one, right? See what I'm saying? You put numbers in front of this guy. We picked a hard one to start out with. You put a number in front of this one, we're going to mess up the sulfurs and the oxygens, right? So, don't. I mean, you're going to start all over again, which is fine, but you're going to start all over again. Everything you've done just got messed up. I wouldn't put them there. Put what right here? 2. Because now our sulfurs, sorry, not sulfurs, our sodiums. 4 sodiums on the reactant side. And we've got 2 sodiums there. And we've got 2 sodiums there. 4. The sodiums work. Okay. Oh, hey, that did work out well, right? Do you have to put anything in front of the I2? Nope. Okay, so you see the game we're playing. See if you can balance these, and then I'll go around and I'll ask the folks around you, or get stuck, ask me. Just balance the element by himself. Balance them last. If you're not sure what I'm asking, just ask. Okay, 6. Oh, there's only 3. Yeah, so, oh, but that's 3 times the 2. That means there's 6 oxygens, but not only 3 C's. So I would just put a 6 in front of that guy. Now the carbons are good. Who's supposed to do last? Do the O's last. Okay, so now the H's. 6 there. All right, now the O's. 12, 13. Oh, that's a good one. I like to cheat on this first one. I don't know. It sounds like cheating, and you're going to call it cheating. But when you did this first one, well, you probably, if you're like me, you just go from left to right. So you had 6 carbons. So you put a. What did you do first? If you do the C's first. You have 6 carbons on the reactant side, so what did you do on the product side? Put a, oh, not a 3 though, because a 3 would give you 6 oxygens, and then only how many carbons? 3. So you have to put a 6. Okay, so we're doing a 6 and 6 there. And then make sure you do which one last? Oxygen. So let's do the hydrogens next. How many hydrogens here? 6. So put a 3. Okay. Now the oxygens. How many oxygens on the product side? How many? 15? 6 times 2 is 12 plus 3. So there is 15. That make sense? Okay. This is where I cheat. How do you get 15 on this side? 15 all over 2. All right? I know, isn't that cheating? I told you wouldn't like it. But it works. Right? Okay, now hang on. We're not quite done yet, though. Because you can't have, what is it? 15 halves is 7.5, right? So you can't have 7 and 1/2 molecules. There you go. Multiply everything through by 2. All right? That's the only, to me, I know it sounds funky, but that's how I do it. So now you have to multiply everything through by 2. But it's good. This will work for everything in general chemistry. Well, I guess minus this section, because they don't like to have fractions there. But for all the math, everything's going to work out. It just doesn't look that nice, though. So let's multiply everything through by 2, though. So we'll get rid of that half. So you'll end up with So what would you end up with in front of the C6H6? A 2. And everybody in front of the oxygen, you end up with a 15. And then in front of the carbon dioxide, 12. And the water, everybody see it? 6. That is the best answer you can give. Okay. So it's kind of a trick. Try the other ones. Compare with the folks around you, see if you're getting the same thing. Hopefully, when you get down to 4, realize in those parentheses, you have to multiply through. You'd actually have 2 nitrogens and 8 hydrogens there with that little 2 down here. 2 nitrogens and 8 hydrogens.
So for number 3, it's Cl, right? This one.
It's HCl. Yeah.
So I'm saying Cl is just one thing. Like this is one thing.
One element.
Yeah.
Correct?
Yes.
Hold on.
Yeah. So there's 5 of them though.
Yeah. Oh,
Yep.
it's gonna, I was thinking that it was C, like carbon. And then
Oh,
I thought it was
oh
C.
no, no.
So I was like,
See that would work. That would work if that L was a capital I.
See, that's what I was
Yeah.
confused. All
Yeah,
right.
because there's an I right there. Next to Z.
Oh, look at that. That should be. Yeah, there should. That's a good point. That should be like that.
So let's put that.
That's a very good point. I never even saw that before.
Let's fill that in with a marker then. Make it.
I know. I can't. I'm not that tall. Though. I'll bring a permanent marker for you next time. Did you get it?
So I started with like the hydrogens,
Okay.
and I see that I have 2 here, and
Yeah.
I have 3 on this side.
Yeah, 4. 3 and 1 is 4.
4, sorry.
Okay.
So I put the 2,
Okay.
and then I have 2 oxygens now.
Yeah.
So like this, and I have 4.
4.
Then I'm like, okay,
Yeah, and yeah. Then
it
see if.
gets-
So what I would do is don't start with the H's and the O's then. Start with these guys. Because if you start with these H's and O's, it looks like you can't mess with them because you're going to screw everything up again.
yeah, see, because then I started, okay, well this is 5. And then over here, I've got nothing's exactly 5.
Yeah.
See,
I think,
I just get all like, it gets all jumbled.
yeah, C5, 5. And then I would leave that, see all the H's, and especially that dang H. He shows up here and here.
Yeah.
I wouldn't do him
Till, like,
first.
last.
Yeah, until last or something. I mean, leave him alone. He'll work out on his own. But the P only shows up here.
Mhm.
The chlorine only shows up there. So I would do him first, like the P or the Cl. You can really be staring at this one for a long time if you start out, I think you're right, in the wrong place. Especially with something like hydrogen, because hydrogen shows up in multiple places. So don't start with anything that shows up in multiple places. I mean, like 3 or more. Like hydrogen, he shows up 1, 2, 3 places. So I wouldn't mess with him.
Okay.
That's the only suggestion I have. Usually you start with something that only shows up in one other place, like the P, or maybe even the Cl, but something like that. The guys who are showing up all over the place, leave them alone.
So, okay, so on his, he got
Mine, I got double hers. Is that fine? Is that the same thing?
or
Oh,
do you want
they're both the exact same thing, mathematically. However, you want the simplest ratio. So you should divide yours through by 2.
Yeah.
And then you'll have hers. Then everyone has the same answer. But it works. You got it. Did anybody get an answer for 3? What'd you get? 4 in front of the H2O? And keep going. What else did you get? 5 in front of here? Oh, the HCl. And then you're done? Wow. Someone else brought up a good point. If you would have had 2, 8, 2, and 10, you just want the simplest ratio. So then everyone would end up with the same answer. Okay. How about 4? That's a long one. I definitely would not mess with what? Man, look at that oxygen. Oxygen's here, 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 here. Do not mess with oxygen. Look at that. That thing is everywhere. Hydrogen, same thing. Hydrogen, 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 hydrogen. Oh, do not mess with hydrogen. Because those guys will fall into place. Nitrogen only shows up there and there. That's a safe place to start. S2, right? S, the sodium. Oh yeah, sodium only shows up there and there. So those are safe places. Don't start with something that shows up in multiple places. Anybody get an answer for 4? Christian, what'd you get? Jessica, what'd you get? Oh yeah, that's a good point. That's realize that this is really N2H8. Good point. Because you have a little 2 down there. So this is really N2H8. Good point.
I started to balance everything on the right using that.
Uh-huh.
So then I got, with the NH3, I put a 2 in front of it.
Okay.
Get too much.
Oh yeah. Then what?
And then, well, there's only one SO4, so I left that alone.
Oh, I like that. See how she's combining those things? Think of this as an SO4. It's over here too. Nice. Okay, good. Keep going.
And then I noticed that there's 2 sodiums on the product side.
Oh, yeah.
So I'm multiplying 2 on the reactant.
Okay. Does that make everything work?
No.
No?
Okay.
Okay.
So then there would be 2 OHs, but since there's only one product of H2O, I have to multiply that by 2.
Let's see. 2 oxygens. Don't forget about these. We have 4 there. So you have 6 total. Oh, and then she put a 2 here. And then you have 2 oxygens, 4 oxygens, 6 oxygens. Wow, that works. That works. Do you see that? You catch that? The number of oxygens on this side, let's erase that 2. She had 4 here and 2 here. That means 6 oxygens on this side. And then you have 4 here. That's why Jessica put a 2 there. You have 6 oxygens on both sides. That works now, right? So you should have a 1 in front of the ammonium sulfate, 2 in front of the sodium hydroxide, 2 in front of the nitrogen trihydride, 2 in front of the dihydrogen monoxide, and a 1 in front of the sodium sulfate. 1 left. Anybody get 5? And a 2. This one?
There's a 3 in the beginning.
Oh, there's 3 in the beginning?
And then we have 2 after the H2O.
A 2 right here?
Yeah. And then to get 3 off the other.
Oh, and 3 doesn't go there? Okay. Man, the oxygens are everywhere. If his oxygens work, it has to work. So we've got, let's practice this. How many oxygens on the, see if you got it. How many oxygens on the reactant side? 7. If you can see 7, you see exactly what's going on here, right? Because 3 times 2 is 6, plus 1 here, 7. Then on the product side, it's 7 again, isn't it? I bet you it's right. All right, I think other folks got it. Okay. So now, you know this is coming up too. See if you can do these without your cheat sheet. See how many you can get through without the cheat sheet. All right? Now remember, if you see a metal, don't count to 10 in Greek. Right? If you see a metal, it's just going to be naming the cation, naming the anion. For example, this very first one, there's no metal there. No metal whatsoever. Right? Because the metals are the whole periodic table. Pretty much, except for the little stair ladder. And there aren't any there. So that means name the cation, Name the anion. Right? And these are those polyatomics. Either you got it memorized or you don't. Right? And if you got to use a cheat sheet, you got to, but maybe someone around you knows it. Does anybody know the name of the first one? Oh, good. Ammonium sulfate is the first one. And you're really on track. Now, you don't really need this, but you're really on track if you understand why there's a little 2 down there. Why? Because the sulfate has a -2. Right. And that's why in the ammonium it's only a plus. So that 2 had to go down there, and that's why there's parentheses around it. Good point. Good job. Try these. Oh, that first one, there is no metal, but it's all polyatomic iron. That first one is hard, right? Because there's no metal. So don't you want to do the mono di-tri stuff? But I guess you just have to recognize polyatomic ions. It's just polyatomic ions stuck together. And that happens with that ammonium. Ammonium is the oddball when it comes to cations. Ammonium sulfate. The next one is going to be sulfide. That next one is going to be sulfide. Right? This guy's a -2. He's a +3. That's where the subscripts are coming from. And this one is something sulfide. What is it? Aluminum. Oh, aluminum is one of those. It's like ammonium, another oddball. You just have to remember, aluminum had no choice on his charge, so you don't put parentheses with his charge. And aluminum is a 3, and you can tell because right here, aluminum's charge had to go down there where the sulfurs, right? Because you do that cross charge thing, balance things. Aluminum has a 2 on it because sulfide has a -2. So you have a few more minutes. Now on the third one down, you're going to have to use parentheses because it's a metal, and it's not aluminum, it's not zinc, and it's not one of the guys in groups 1 or 2. So you have to use parentheses. The only time you didn't on metals is if it's in group 1 or 2, or aluminum or zinc. Yes? Oh, it's so close. Just have the 3 right there. 3 is after the iron. You put it in Roman, you go right here.
Okay, so I put the Roman numeral.
You put the Roman numeral right there. You always do it for all the metals, except for zinc and aluminum, because zinc is always +2, aluminum is always +3. And you never do it either with the elements that are metals that their charge is fixed. And that was the group 1 and the group 2. But everything else, all these group Bs, all these transition metal elements, you always put the charge in parentheses, unless it's aluminum or zinc. You'll get it. It takes practice. Good. I see a lot of iron 3 hydroxides. And the 3 has to be in parentheses. On the next one down, you don't see any polyatomic ions. You don't see any metals. That's a counting to 10 in Greek problem. And adding IDE to the end. Now in lab this week, make sure you bring your cheat sheet because it's we're going to play Chemical Feud, and your teammates are not going to want you on their team if you don't have a clue. So you might want to bring your cheat sheet. Or a Chemical Feud, whatever it's called. How'd you name NH3? Oh yeah, it is ammonia, but the technical word would be mono, nitrogen, trihydride. Mono, nitrogen. You can drop off the mono if you want, but mono, nitrogen, trihydride. Yep, hydride. So we're about out of time. So come by if you have some questions. I can quiz you on this stuff if you want. And bring the cheat sheets to lab.